In this video, I'm going to go over our very last topic for trigonometry, and this is actually converting, or I guess first plotting what a polar coordinate is, and this is using our understanding of the unit circle that we've talked about since the very first unit in January. And then we'll talk about converting between polar coordinates into rectangular coordinates, and rectangular coordinates are just essentially the coordinates that you are used to from your days of middle school, like the x-axis and the y-axis. And then finally going the other way, converting from rectangular coordinates to polar coordinates, okay? So let me first start by plotting some of these, and I think you'll kind of get used to it, the different iterations of it. But the kind of the setup here is it's always going to be r comma theta, and the way I always think of this is r is the radius, or that distance from the center of the unit circle out, and then obviously theta is our angle. All right, and if the angle is positive, we'll be moving in a counterclockwise direction. If the angle is negative, we'll be moving in a clockwise direction. So let's do the first one. This is the most straightforward. Both are positive. So I'm going to start with pi over 3. All right, so I start here, and I move in a counterclockwise direction to pi over 3. All right, so I found it. Here's pi over 3. And how far I draw from the center of my circle out on that angle pi over 3 is this radius of 2. So I've got that point is here, all right? And I'm not sure in your days of physics if you went over this, but if you draw from the center out with that arrow, this is called a vector, all right? It has a distance of 2, all right? But again, I just care about that point. I'll call it point A, all right? That point is A. Okay, let me do the same thing for the next one. All right, I'll call this point B, all right? So in this case, I'm going to start with my theta again, right? I'm going to pi over 6. Here it is. But you'll notice my r is negative. So what that means is the direction of my vector, if I were to draw it, just has to move the other direction. So instead of moving towards pi over 6, right, most students will think it's going to be here for a positive 2. We actually have to move the other direction and move over here to negative 2. So that's 2 units the other direction. All right. What you can do if you need any help with this is if you take pi and subtract it, or if you take pi and add it, right? Your choice on how you want to do this. But if I rewrote that as 6 pi over 6 plus pi over 6, you would get 7 pi over 6, which if you notice, that's the theta that I end up with. If you did the other way and subtracted, you'd actually get negative 5 pi over 6, which again would be the same. You're just working in a clockwise direction for negative. So I don't really care. It's your choice. You don't really have to do that. But if you're just concerned about, do I know which angle to move towards? I think it's pretty straightforward. Just kind of see moving across the center of this unit circle. But if you want to do this extra algebra, you can. All right, so let's plot these last two. I'll plot this one as angle C. Again, this is a negative, or a plot point C. This is a negative pi over 6. So I'm moving in a clockwise direction. So that would be here, would be 1 pi over 6 in a negative direction. And I've got going 1, 2, 3, 1, 2, 3. So I'll call this point C. And then finally, I'll plot this last one as point D. And what you should notice is this angle is actually more than one rotation all the way around, right? It has a denominator of 4. So 2 pi changed to a denominator of 4 is 8 pi over 4. So actually, we're going to move one entire circle around, a rotation around, and then finish with 1 pi over 4 left. So right here is 1 pi over 4, and moving 2 units out will get us to that point there. All right, so that's a little bit about plotting polar coordinates. You'll have a Delta Math link to help you graphing these. All right, so let's do some converting. We're going to start with by them giving us polar coordinates. All right, so again, giving us that r comma theta. And we're going to take those polar coordinates and convert them to rectangular coordinates, which is just an x and a y. And using this graph that we've used a ton in this whole semester of trigonometry, remember for theta here, if I use the cosine, which is adjacent over hypotenuse, you can think of this as the adjacent side is x, and the hypotenuse we're saying is letter r. All right, so that's where they get this from. And then if you were to just move that r to the other side with algebra, with multiplication, you end up getting this way that we'll use to convert from our polar coordinate, which is r comma theta, to our rectangular coordinates. Sine is the same thing, just a little bit of a twist, right? You have opposite over hypotenuse, which is y over r. Again, that's where they get this. All right, so opposite is y over the hypotenuse. And then if you move that r over, again, with multiplication, you end up with this formula here. So I'll really just be using this after it's been reorganized, reshuffled, okay? But again, I don't want you to think this came out of nowhere. It's coming from our days, right? This was one from the very first unit. Really, that's from your days in geometry. All right, so let's use that. All right, so I'm going to write it here. X equals r times the cosine of theta. Y equals r times the sine of theta. And again, they're giving me polar coordinates, which are r comma theta. So I'll be using these formulas to find the x and y rectangular coordinates. All right, so here we go. Here's x. X equals my radius times the cosine of pi over 2, and y equals my radius times the sine of pi over 2. Now, my alarm bells are going off, right? This is a quadrantal, right? Pi over 2 is up here, and the ordered pair for pi over 2 is going to be 0, 1. If you remember your days in quadrantals, we've been using them pretty much every unit. It's cosine, sine for the x and y values. So in this case, I'm going to have 3 times the cosine, the x value, which is 0, and this second one, which is going to be 3 times the sine of pi over 2, which is the y value of 1. So 3 times 1 is 3. So my rectangular coordinates are 0, 3. So this right here would be the rectangular coordinates that associate with that polar coordinates. So if you were to graph both of them, you get the same thing. Okay, let's do the next one. So x equals my radius of negative 2 times the cosine of 0. Y equals negative 2 times the sine of 0. Another quadrantal, so I'll rewrite it down here, or you can keep going on that same one up there. This time it's 0 radians, with that ordered pair at that point will be 1, 0. Again, thinking cosine in the x, sine in the y value. So the cosine of 0 is going to be 1, so negative 2 times 1, which is negative 2. And the sine of 0 is 0, right? That y value is 0. And negative 2 times 0 is 0. So my rectangular coordinates will be negative 2, 0. All right, again, that matches this. Shouldn't really confuse you, or maybe it does confuse you, and that's okay, right? This is the radius and our angle theta. And if you were to graph an angle of 0, right, you're on the x-axis, right, and you're moving in that direction, all right, to get that value. So that's why we have the same thing there. Okay, let's do the next one. All right, so our last one here, right, this is r comma theta. So we're going to do x equals r times the cosine of theta. Actually, let's put it in here. Negative 1 times the cosine of 2 pi over 3, and y equals negative 1 times the sine of 2 pi over 3. So in this case, I'm going to do negative 1 times, and I'm going to do a quick little sketch here. Again, if you don't need a sketch, that's fine. But 2 pi over 3 is going to be in the second quadrant, right? Finishes here. This is 2 pi over 3. And the way I taught you guys to do this in the in the first unit was to find the reference angle. All right, I'm hoping you remember me telling you that whatever the denominator is will be the dead giveaway. So it's pi over 3. So really I'm asking myself, what is the cosine of pi over 3? All right, the cosine of pi over 3 is 1/2. So I'm going to write 1/2, but what quadrant did I end up in? And 2 pi over 3 ends up in the second quadrant. So according to all students take classes, that means it's going to need to be negative. All right, so negative 1 times negative 1/2 is positive 1/2. Let's do the same thing with this other one. So now I'm doing the sine of my reference angle and the sine of the square root of pi over 3 is the square root of 3 over 2. All right. But again, because I'm in the second quadrant, I actually get to keep that as a positive, right? All students, S stands for sign. So that's positive square root of 3 over 2. So when you multiply this, you get negative square root of 3 over 2. All right, so my ordered pair here in terms of the rectangular coordinates is 1/2 comma negative square root of 3 over 2. All right, so that's it for this going from polar coordinates to rectangular coordinates. All right, okay, so now let's go the other way. So going the other way, we have our same triangle that we just looked at. All right, but now what we're going to do is they're going to give us x and they're going to give us y. So if we know the two side lengths of a right triangle, we can use the Pythagorean theorem, which is this right here, to find the hypotenuse, or letter r. So that's how we're going to find the first part of the polar coordinate, right? Remember, we're trying to find r comma theta. And then to find theta, if we know x and y, right, remember tangent of theta equals opposite over adjacent, right? So opposite is my y value, adjacent is my side length x. So we'll be using the tangent function to find that ratio. And I'll be using, even if there are some negatives, I'll be making them all positive to find a reference angle. And then once I find that reference angle, I'll use that to find out where my actual theta is going to be. All right, you'll see in a few examples here. All right, so let's plot 3 comma 3, right? 3 comma 3 is out here. So that would mean if I draw my triangle, I've got an x value of 3. I've got a y value of 3. So if I'm trying to find the r, or hypotenuse, right, I'm going to be using the Pythagorean theorem. So x squared plus y squared equals r squared, or 3 squared plus 3 squared equals r squared. So that's 9 plus 9, which is 18. And so if I take the square root of both sides, I get the square root of 18. I don't need to worry about plus or minus, right? We talked about this ever since the first unit, that your hypotenuse, or your letter r, will always be positive. So my r value is the square root of 18. You don't need to simplify it. I know I've made you guys do that in the past. You can just leave it as the square root of 18. Now, to find the theta, right, remember this is my theta, I'm going to do tangent of theta first, which is the opposite over adjacent, or 3 over 3, okay? Now, when I do this, I'm going to find the reference angle. You're going to see that since we're in the first quadrant, this reference angle is going to be my theta. But I want you to practice this step of doing tangent to the negative first power. We've done that many times now. If any of these were negative, I would change them to be positive, but they're not. So that's really tangent to the negative first power of 1. I'm hoping you know this one from your table. The tangent to the negative first power of 1, so the tangent of what angle gives us 1 would be pi over 4. So that's actually our theta, right? Remember, we're in the first quadrant. So my polar coordinate here is going to be r, which is the square root of 18, and theta, which is pi over 4. So this right here is our answer. Okay, let's try another one. Let's graph this one, which is going to be negative 6. So I'm moving to the left for negative 6. And I'm moving down for negative 2 square root of 3. So I'm going to draw, this is my triangle. So x equals negative 6, and y equals negative 2 times the square root of 3. So I'm going to try to find r with the Pythagorean theorem. So negative 6 squared plus negative 2 times the square root of 3 squared equals r squared. If you want to use decimals, you can. I don't think you need it. 36 plus, now be careful here, the square root of 3, that's inside the radical, so when you square that, that's just a 3. But the negative 2 squared is a positive 4, so 4 times 3 would give you 12. So r squared equals 48, so r equals the square root of 48. Again, you do not need to simplify this. I know you can, but just leave that as the square root of 48. So we found r. Now let's find our theta, right? So tangent of theta is going to be equal to the opposite, right? So here's theta. Opposite, which is negative 2 times the square root of 3 over adjacent, which is negative 6. So when I do my reference angle, I'm going to do tangent to the negative first power of, and take away the negatives here, guys. I know it's going to be positive anyway, but just always take away any negatives. Let's reduce that. Tangent to the negative first power of, that actually reduces to the square root of 3 over 3. So you actually should know this one from your table. Tangent of some angle is the square root of 3 over 3. That's going to be pi over 6. Again, that's my reference angle. You notice, where did I draw this? I drew this in the third quadrant. So to find my actual angle theta, what we need to do, use a different color here, is we need to take that reference angle, right, which is going to be pi over 6, and add it to pi. So theta is going to be pi plus our reference angle of pi over 6. Get a common denominator, 6 pi over 6 plus pi over 6, which equals 7 pi over 6. So my answer in polar coordinates, again, remember, is r. So r, square root of 48, theta, 7 pi over 6. Now, you'll notice I'm always going to be using theta as positive values, but obviously theta of negative values is doable. So the other way here would be going clockwise, would be negative 5 pi over 6. Okay, so that's it for the second one. Let's do one more, and then we'll be all done. All right, so I wanted to give you one of these kind of unique ones. We're plotting 0, right? 0, 6 square root of 3. So 0, 6 times the square root of 3. And what you should notice is we actually can't make a triangle here, right? If we plot this, you should see that this radius is just that distance from the center up to that point. So that radius actually is 6 times the square root of 3. So that is, even though it's my y value, it's actually also my r. And then to find the theta, I'm hoping you're thinking, oh, this is a quadrantal, right? And the point up here, that quadrantal, or that angle, is going to be pi over 2 up there. So my r and theta is going to be 6 times the square root of 3, and my angle is pi over 2. All right, so that, I think, even though that's a little tricky because it's a quadrantal, once you sort that out, it actually ends up being one of the simpler ones, at least in terms of the least amount of work. So that's it for going from rectangular coordinates to polar coordinates. You'll have delta math links for all three of these things: graphing, polar coordinates, converting from polar form to rectangular coordinates, and then going the last way we did, which was rectangular coordinates into polar form. Good luck.